I'm going to divide the x by everything to get this dy dx by itself here. So when I do that, I have so it's going to look like that, right? So now this does look like a linear equation. So I see right here this 4 over x. This is going to be our p of x. So we're going to find the integrating factor here. We're going to have e raised to the integral of the p of x dx. It's going to be e to the integral of 4 over x dx. It's going to be e to the 4 ln x, which is going to equal x to the 4th. So this is our integrating factor right here. I'm going to multiply this by both sides of our equation right here. So when I do that, it's going to be 4 over x. Alright, so it's going to be like that. Then I'm going to go ahead and distribute that. We're going to have dy dx x to the 4th plus 4x cubed y equals x to the 6th minus x to the 4th. Right? So now we see right here, this is going to be, you can see we have product rule here, right? We have f right here, f prime goes right here, our g, and our g prime. So that means I can rewrite this left-hand side as d dx x to the 4th times y. It's going to equal x to the 6th minus x to the 4th. I'm going to go ahead and I'm going to integrate both sides of the equation with respect to x. So we're going to get x to the 4th y on the left side. We're going to have x to the 7th divided by 7 minus x to the 5th divided by 5 plus c. Alright, so now to isolate the y, I'm going to divide the x to the 4th by both sides. So I'm going to do that. I'm going to have x to the 3rd over 7th minus x over 5 plus c. Alright, so this is our general solution. So now to find our real solution, I'm going to substitute this y of 1 in right here. So y of 1 is equal to 0 equals 1 cubed over 7 minus 1 over 5 plus c. So we're going to have 0 equals 1 over 7th minus 1 over 5 plus c. Okay, now to combine those, so we're going to have minus 2 over 35 plus c equals 0. Just add that to the other side, so c equals 2 over 35. So resubstituting that back in to our equation over here, our final answer is going to be y equals x cubed over 7 minus x over 5 plus 2 over 35. Right? Oh no, that's not right. Sorry. You have an x to the 4th underneath the c right there. Alright, hold on. Let's back up a little bit here. Alright, so we have our x to the 4th underneath there. I guess it wouldn't have really changed anything because it would have been 1 to the 4th anyways. So we'll still have our 5 over 35 minus 7 over 5 plus c. C equals 2 over 35. So I guess it wouldn't have changed too much here. We're just going to have 2 over 35 above x to the 4th plus 2 over 35 over 4th. So yeah, that's going to be our final answer right there, and that is number 2. It wasn't too bad. Okay, for number 3 here, we have dy dt minus 3y equals t e 3t. Okay. this right off the bat, this just looks linear. So I can see we have our p of t right here as minus 3. So we'll just do basically the same thing. We have our e to the integral p of t dt equals e integral minus 3 equals e minus 3 t. Okay, so multiply that by both sides of the equation. E minus 3t times dy dt minus 3y e to the minus 3t t e to the 3t. Okay, so on the right hand side here, I know this and this e are just going to cancel out because this one's going to go in the denominator right here. So on the right hand side, we're just left with t. Once again, here with the integrating factor on this side, we know it's just going to result in product rule, so I'm just going to skip writing all that out. But I do know that it is going to look like that. Hopefully that's alright with you. You don't take points off for that, but hopefully I've demonstrated I understand what's going to happen here. So we're going to have e to the minus 3t times y. Alright, so we're going to integrate both sides. We have e to the minus 3t times y equals t squared over 2, right, dt plus c. So to isolate y, we're going to divide both sides by e to the minus 3t. Alright, so now to solve for c, I'm going to plug in the initial condition here. So y is 0 equals 5 equals 0 squared over 2 e to the minus 3, 0 plus c over e to the minus 3, 0. So 5 is going to equal to, this is going to 0 out right here, plus c. Now e to the 0 here, that's just going to be 1, so it's going to be c over 1. So our c here is equal to 5. That's pretty easy. So our final answer is going to be y equals t squared over 2 e to the minus 3t plus 5 over e to the minus 3t. Final answer. And camera doesn't pick that up too good, but I hope you can kind of see that. Alright. I'm going to skip number 4 for now because you don't want to watch me do that. And we'll just do number 5 right now. Alright. Assume Newton's law of heating and cooling applies. A dead body was found in a walk-in freezer at 8 a.m. The temperature of the body was 30 degrees. At 10 a.m. the temperature had cooled to 25 degrees. Freezers kept at a constant temperature of 10 degrees, that's our ambient. Body's temperature, time of death was 98.6, so I guess that's going to be our initial temperature. 98.6 degrees. And on you gave us the Newton's law of heating and cooling formula here, so I'm going to use that. Equals K, T minus Tm. Okay, so here's where we're starting here. Does that look good? Yeah, you can see that. Okay. So the first thing I'm going to do here, this is a separable equation, so I'm going to go ahead and solve the differential equation so we can figure out the exact time of death here. So to do that, we're going to have dt over t minus tm equals k dt. Like that, right? We see how it's separated. So now I'm going to integrate both sides. Okay, so left hand side here. So I use u substitution. I'm pretty sure that's just going to be ln of t minus tm. So I think tm is just a constant, right? So Yeah, yeah. It's going to be like that. So then we're going to have k times t over here plus c. Alright, we're going to need to find our c. Okay, first we'll isolate for t. So we'll raise both sides here to the e. So it's going to result in t minus tm equals e to the kt plus c. Now this right side here, okay, I'm going to put the c up higher. When it's up in there, we can just rewrite that as c e to the kt. So t equals e to the kt, or c, that, yeah, e to the kt plus tm, isolate. Now we're going to plug in our initial condition here and solve for c. So we have the initial equals c e to the k0 plus tm. So this right here is just going to go to 1 right here. So initial temperature equals c plus tm. C equals T0 minus Tm. Okay, so plug that back in. So the equation we're working with is going to be T equals T0 minus Tm e to the kt plus Tm. Okay, so now we need to find when he initially died, when the body was at 98.6 degrees. Actually, you know what? I'm actually not going to use 98.6 the initial temperature. I'm going to use, let's use 30 as the initial temperature. Yeah, so 30 is going to be our initial. So our T right here, I'm going to use 25, and then for the time, I'm going to use 2, because I do need to calculate this K right here, right? So I'll just use that, and I'll calculate our T, and then we'll move on to that next part. So we have 25 equals initial temperature of 30 minus the ambient, which was given as 10 degrees, right? Yeah, 10 degrees. E to the K, we're using 2 for T here, because it's been 2 hours, here in the given problem. Plus 10, 25 equals 20, e to the 2k plus 10. So subtracting 10 from both sides, we'll have 15 equals 20 e to the 2k. So 15 over 20 equals e 2k. We'll take the natural log of both sides to help isolate this k here. So this is really fucking uncomfortable. Alright, so our k is going to be equal to ln of 15 over 20 divided by 2. Right here. Wow, this camera sucks. I'm sorry. Yeah, you can kind of see that. Alright. I'm going to throw this in a calculator and see what it gives me here. Okay, so I'm getting minus 1.44 or 0.144 for our k value. Okay, so let's reset up the equation here. We can have T equals T0 minus Tm e minus 0.144 T plus. Okay, kind of see that. Alright, so now I'm going to plug in 98.6 for our T right here. And then the only unknown information we're going to have is this time variable right here from when he was at 98.6. So we'll use that and we'll solve for that T, and then we'll kind of work backwards and figure out when exactly he died. So we're going to have a 98.6 88.6 equals, what did I say the initial was? 30. 30 minus 10 equals 4t. Right here. Yeah. Alright, so we'll subtract 10 from both sides. 88.6 equals 20 e to the minus 0.144t. Okay, we'll divide by 20. So, gonna have 4.43 equals e to the minus 0.144t. Like that. Alright, to isolate the t, we're going to take the natural log of both sides, so ln of 4.43 equals minus 0.144t. So now we'll divide both sides by minus 0.144. Alright, so this value is going to give us our t. The time of when he was at 98.6 degrees, you know, when he just freshly died. So typing all that in, I'm getting minus 10.34 hours. Okay, so that means he died 10 hours before, before 10 a.m. I guess, because I used because when we solve for this k value here, we are already using time t, or for time of 2 hours, which would be 10 o'clock. So subtracting 10 hours, 10.34 hours from that, he would have died at like, what is that, like 11:40 p.m. or something. So it's in that ballpark, but yeah, that's that. Alright, finish up the rest of the exam, but that was my, this is my video portion for problems 2, 3, and 5.